everybody. Today, we're going to talk about Chebyshev's theorem. Chebyshev's theorem gives us an idea about how much percent of the data falls in a certain range if we only knew the mean and standard deviation. And this works for any set of data. By that I mean, the distribution of data does not matter. The distribution can be normal or skewed or uniform or J-shaped or U-shaped. It doesn't matter what the distribution of data is. Chebyshev's theorem will work for any kind of data we can think of. Chebyshev's theorem says that at least 1 minus 1 over k squared of all the data falls between x bar minus ks and x bar plus ks. Let's look at some specific cases. When k is 2, we have at least 75%. When k is 3, we have at least 88.9%. And when k is equal to 4, we have at least 93.8%. And schematically, here's what it looks like. At least 75% fall between x bar minus 2s and x bar plus 2s, where the mean is in the center right there. And we have that at least 88.9% of the data falls between x bar minus 3s and x bar plus 3s. And we have at least 93.8% of the data falls between x bar minus 4s and x bar plus 4s. As you can see, the ranges get larger and larger and larger as we go from 2s to 3s to 4s and so forth. Let's look at some example problems. Let's suppose that a set of data is skewed to the right with mean is equal to 61.96 inches and standard deviation equals 45.6 inches. And let's not restrict it to inches. Let's just say we have some number 61.96 for the mean, and we have some number 45.6 for the standard deviation. According to Chebyshev's theorem, at least 75% of the numbers are between which two numbers for which the mean is the center. Well, if we just focus on those specific cases, we just want to find which case is for at least 75%. And if we look at the theorem here, at least 75% refers to x bar minus 2s and x bar plus 2s. And so we just have to calculate those things, okay? And by the way, x bar is the mean, s is the standard deviation. And so we have at least 75% of the data that fall between the mean minus 2 times the standard deviation falls between the mean minus 2 times the standard deviation and mean plus 2 times the standard deviation. So let's go ahead and calculate those. X bar minus 2s. Okay, now x bar is the mean, which is given as 61.96, so we'll go ahead and put that in there. Minus 2 times s, that would be the standard deviation, which is given at 45.6. Two times 45.6 is 91.2. And 61.96 minus 91.2 is negative 29.24. All right, and we'll do x bar plus 2s. That's going to be equal to 61.96 plus 2 times 45.6. That's going to be 61.96 plus 91.2. And if I add those numbers, I get 153.16. Okay, so this says at least 75% of the numbers fall between negative 29.24 and 153.16. So the answer is between negative 29.24 and 153.16. Next, let's do this question. According to Chebyshev's theorem, at least 93.8% of the numbers are between which two numbers for which the mean is the center? All right, again, we refer to the Chebyshev's theorem and figure out what the case of 93.8% looks like. Well, let's see here. It says at least 93.8% of the data fall in the interval from x bar minus 4s and x bar plus 4s. And so all we need to do is tabulate x bar minus 4s and x bar plus 4s. All right, doing so. Let's see, x bar was 61.96 minus 4 times s. S is going to be 45.6. Let's see, 4 times 45.6 is 182.4. (61.96 minus 182.4 is negative 120.44. Now let's tabulate x bar plus 4s. That's going to be 61.96 plus 4 times 45.6. That's 61.96 plus 182.4. And that's going to bring us to 244.36. Okay, so this says at least 93.8% of all the numbers are between negative 120.44 and 244.36. Right? Now we have this next question that says at least what percent of the numbers fall between negative 74.86 and 198.76. And let's just assume we're going to apply the Chebyshev's theorem. Okay, now it doesn't say to apply the Chebyshev's theorem, so we could answer this question in any way that we wanted to, but let's go ahead and just apply the Chebyshev's theorem because we have it. Okay, so we want to know what percent. Okay, now if I stick to the specific cases we have, the answer is either going to be at least 75%, or at least 88.9%, or at least 93.8%. So looking back at what we have here, we said that at least 93.8% fall between negative 120.44 and 244.36. However, we're given between negative 74.86 and 198.76. And so the answer cannot be at least 93.8%. So let's backtrack and see about this one. Okay, now this one talks about at least 75% of all the numbers are between negative 29.24 and 153.16, but we're not given those numbers either, right? Because we're given between negative 74.86 and 198.76, which is not the same as between negative 29.24 and 153.16. So the answer cannot be at least 75%. So it might be the other percentage that we didn't look at yet, which was at least 88.9%. It might be another percentage as well because Chebyshev's theorem is not necessarily restricted to those specific cases, okay? So let's just suppose we believe that the answer is at least 88.9%. In that case, we would just try out x bar minus 3s and x bar plus 3s and see if that matches with what's given. Okay, so let's see what happens. X bar minus 3s. Let's see, x bar is going to be 61.96 minus 3 times s. It was 45.6. Okay, now let's have like 3 times 45.6. That's going to be 136.8. All right, and do the math, we have a negative 74.86, which is what we wanted. Okay, but now let's hope that we also get 198.76. To test that, let's calculate x bar plus 3s. In doing so, we have 61.96 plus 3 times 45.6. And that's equal to 61.96 plus 136.8. And that comes out to 198.76, which is what we wanted. Pretty cool, wasn't it? All right, so since that matches with what's given, then our guess is right. And so we can definitely say at least. And whatever it is that corresponds with 3s, let's review what that is. So for 3s, that deals with at least 88.9%. And so at least 88.9% is the answer. Now notice that we got all of those results by just simply having the mean and the standard deviation. So we don't have to be given the data, right? So we're just getting a result based solely on the mean and the standard deviation. However, we actually do have the data for this problem. And so it'd be interesting to compare with what the actual data is with the results of Chebyshev's theorem. Okay, so here we said first that at least 75% of the numbers occur between negative 29.24 and 153.16. Here's the original data. The data is actually all of the number of counties, parishes, divisions of each state of the 50 US states. So for example, there's one state that has 3 counties or parishes or divisions, and that actually happens to be Delaware, which is our first state. And the highest number is 254. That refers to the 254 counties of Texas, okay? Okay, so, all right, so let's see how many of these numbers are between negative 29.24 and 153.16. Okay, well, none of these numbers are negative, so the first number that occurs, that's the first number that is higher than negative 29.24 is the 3. All right, and we need the number that comes right before 153.16, and that's going to be the 120. Okay, so between negative 29.24 and 153.16 are all of these numbers here from 3 to 120, and that's 48 out of 50 states. All right, 48 out of 50 is equal to 96%. And 96%, is that at least 75%? Actually, it is, because at least 75% means 75% or greater. So yes, 96% is 75% or greater, and so that verifies that result. All right, now the next result We'll come back to the at least 93.8% case in a minute. So right now, let's go to the case of at least 88.9%. So here, according to Chebyshev's theorem, at least 88.9% of all the numbers fall between negative 74.86 and 198.76. So let's see how many numbers in the data of states are like that. Okay, then we want to stop at 198.76, and that means this time we'll include that 159, which is the number of counties of California. Okay, so this means we're dealing with 49 out of the 50 numbers, and that's going to be 95%. And is 95% at least 88.9%? It sure is. So that verifies that to be true. Now let's go to the final case, which was the fact that at least 93.8% fall between negative 120.44 and 244.36. And looks like we're still stuck with just the 49 numbers because 254 falls outside of that range. So is 95% at least 93.8%? Yes, it sure is. And so all of this verifies Chebyshev's theorem beautifully. And that's how to apply Chebyshev's theorem.